morning, students. Today we are going to see about the lab experiment. The name of the experiment is bending test on mild steel rod. So now I share my PPT. So the bending stress on mild steel rod is available in the virtual lab. The test is carried out by using universal testing machine. Universal testing machine. Then I change my slide. Then this the before doing the experiment, we should know about types of beam and then loading condition, as well as what is mean by deflection. There are 5 types of beam: cantilever beam, simply supported beam, overhanging beam, continuous beam, then fixed beam. Okay. Then deflection means when the beam is deflected due to the application of the external force. It is called as deflection. Then there are the bending test is carried out in the mild steel rod. By using a universal testing machine. So in the universal testing machine, there are 2 types of methods there. First one is the 3-point bending test, and second one is the 4-point bending test. So now we are going to do 3-point bending stress. So in 3-point bending stress, so we are going to fix the deflector in the 3 points. 3 points means at the mid of the span and 1/3 of the specimen. In 3 points, we are going to fix the deflectometer. Then we are going to note the deflections at the each point, mid of the point as well as 1/3 of the specimen. Then we are going to solve what is the procedure to do the experiment. So this next slide. Then the first step, measure the dimensions of the test specimen by using vernier caliper into perpendicular direction. Then step number 2 is measure the length of the specimen. And step number 3, mark with chalk in midpoint and 1/3 length of the specimen where dial gauges will be placed. Then step number 4, place the specimen on UTM and set the dial gauges as 0. And sixth step, start the UTM and denote the deflection under applied load in mid and 1/3 length of the specimen. So apply the load at the apply the load when the yield point of the specimen is reached. So yield point means it is a permanent bend of the specimen. It is called as yield point of the specimen. So beyond the yield point, the material will be broken. So you will give the load up to the yield point of the specimen. Then after the test, you have to note the values of the deflection at each point, midpoint as well as 1/3 of the specimen. And the last step is the plot the graph between load versus deflection at midspan. Then the second graph plot the graph between theoretical and the actual deflection at 1/3 of the specimen. So these are the procedure. So now we are shift to virtual lab. How this experiment done with the use of the virtual lab. So now I am going to share the virtual lab video. So kindly listen. So now I share my virtual lab. So this is the virtual lab. So in this virtual lab, there are a lot of experiments are there. So now we are going to see the bending stress on mild steel rod. So I already explained the procedure to do the experiment. Then it is the diagram, is the UTM machine diagram. So now we are stimulate the experiment. How the experiment is doing real time laboratory. So this is the virtual lab. So in virtual lab and real time experiment both are same. So here we just stimulate what will be done with the virtual lab and actual laboratory. So now I switch over to virtual lab. So here there are a lot of icons are there. So select the simulator. So objective is to study the behavior of mild steel rod subjected to gradual increasing equal load at one third of the specimen and determine the mechanical properties. So mechanical properties means deflection at the each point. Mid-span of the specimen as well as deflection at one third of the specimen. Then apparatus is a universal destination, dial indicator, scale and vernier calipers. So scale and vernier calipers is the accessories. So now I simulate. So click here, it is a virtual lab. So first step, measure the initial diameter of the bending test specimen to perpendicular direction using vernier caliper. So here, so takes the specimen, then measure the specimen on both the direction, perpendicular direction. So these are the two values. This is the average value of the diameter of the specimen. So then you calculate the area as well as moment of inertia. So moment of inertia for a circular rod is pi by 64 into d power 4. D is the average diameter. Okay, D is the average diameter. So now these are the values of area as well as moment of inertia. So then the next step number 2 is the measure the length of the specimen. So length of the specimen is 690 mm. Number 3, mark the length of specimen as well as one third of the length of where the dial gauge will be located. So it is a total length is 690. So this is the wingspan, and these 2 points are 1/3 of the length of the specimen. Then fix the step number 4 is fix the specimen on the mild specimen on the UTM machine. Then click. The specimen is fixed between the dial gauge. So this is the deflector. The deflector give the deflection reading when the load is applied on the mild steel specimen. The deflector gives the deflection reading. Then step number 5, switch on the machine and give the load gradually and denote the deflection of the specimen on midspan of the specimen as well as 1/3 length of the specimen. I switch on the machine. So the load is gradually given. The load is in kg. So it is a dial reading at the midspan. It is the 1/3 of the specimen. 1/3 of the specimen, we take the average value. We take 1/3 of the specimen in 2 points. Okay, in 2 points already you saw in with the chalk we are placing on more than 2 places. So fix the dial gauges on 2 places at 1/3 of the length of specimen. So take the dial gauge reading, deflectometer reading. So and is the average of the two values. Okay, then it is the dial gauge reading, dial indicator reading at midspan. Then it is the final reading of the dial indicator reading 1/3 of the specimen. These are the deflection under the different load. Now I stop the machine. Then load the specimen until the yield point is reached. So yield point means it's a permanent deflection of the specimen. So beyond the yielding point, the material will be broken. Okay, then the next steps plot the graph between deflection as well as load as well as deformation at the midspan. So it is the linear graph. Then next graph is plot the theoretical deflection at 1/3 of the specimen, which is average experimental deflection at 1/3 of the specimen. It is also linear curve. So it is the experiment. So it is the virtual lab. Purely in our actual lab also this type of procedure we are going to follow. Okay. Thank you. Thank you for listening.